So welcome back to part B of lecture 2. So here in this part we will see from where we have left in the last part. So in the last part we saw about this various just a minute. So in the last part we saw about this various other numeric codes. So these numeric codes are weighted codes, then non-weighted codes, sequential codes, cyclic codes. This all we saw in our last class. Now let's see the BCD codes in detail. And the remaining type of, in the classification we have seen various type of codes. So we will see some of the remaining codes in this part, and if still some remains, then in the next part or in the further parts. So let's talk about the BCD codes. So BCD stands for binary coded decimal. So all the binary codes which are binary codes for decimal number system, so they are called BCD. So BCD are all weighted codes. So for every, let's say here in this table, I'll try to show you that what are the various BCD codes. For every decimal digit, we will see the respective BCD code, and then we will see that how the codes are formed and what are the properties of these various codes. So let's say in this table, if you see, so you can see that here there are decimal digits, and here we have three weighted codes. We have used three weighted codes to show each of the decimal digits. So there are three this BCD codes. 8421 is a BCD code. 2421 is also a BCD code. 642 minus 3. These are the weights. So this is also another BCD code. But the thing is that usually this is the general, like these all are BCD codes. Whereas this 8421 particularly is also called as the natural BCD code. And this BCD code is so much, this 8421 code is called natural BCD, because if we don't do anything and we just see the values of 2 to the power 0 starting from the LSB, then the weights for each place will be, let's say 2 to the power 0, so this will be 1. Then 2 to the power 1 is equal to 2. 2 to the power 2 is equal to 4, and then 2 to the power 3 is equal to 8. So you see, this is the natural way of writing the powers of 2. Now as this particular 8421 is coming in the same order as of the natural order of the natural power of the 2's. So that is why this is called the natural BCD code. And it is also very much like the way in which we show our binary numbers. So these binary numbers up to 15 if we write, so they are written usually in the 8421 code. That is why this is the natural way to convert a decimal number to the binary number. Okay. Here in this 8421 code, the only difference is that we use only first 10 symbols. If we try to write the binary equivalent of all the possible decimal numbers of the 4 possible combinations of these 4 bits, then we can form up to 16 numbers. So binary will go from 0 to 15, but in BCD or natural BCD, this BCD or natural BCD, natural we don't call it always, we just call it BCD. So 8421 is usually called as BCD. Other codes, though they are BCD codes, but not very much popular. So whenever we say BCD, it is usually for 8421 code. Okay, so the difference between the binary number and the 8421 code is that in BCD we use only 0 to 9 symbols. Okay, the code word for 0 from 0 to 9 only, whereas in binary we start from 0 up to 15. So in BCD, if we try to write the numbers in BCD code or 8421 code or natural code, natural BCD code, then what we can say is there are only 10 valid states or legal states or the legal counts, whereas the remaining, that is from 11 to 15, they are illegal counts or they are illegal codes or they are invalid codes. So this we should remember, and not only in 8421 but in any other coding system, in any other weighted code systems, we use to represent this particular coding style to represent the numbers from 0 to 9 only. Okay, so this is how we represent. Now let us see the code word for each of them. So I'll pick a randomly pick up a code word from each of them, and we'll try to show you that why it is like equivalent for that particular decimal number. So let's say I pick this particular code. So for 8421, so you see the weights for 8 and 4 are 0 and 0. So if I try to write the equivalent, binary equivalent of this particular thing, so what I will get is, see, this one should be multiplied with 2. This one should be multiplied with 1. So the sum of these two, because in the last slide we saw that how to represent the number in general form, multiplying the place value with the face value. So the total number is nothing but the sum of the product of the face value with the place value. So in this case, this will be 2 plus 1. So 2 into 1 is 2 and 1 into 1 is 1. So 2 plus 1. So you see, this is coming equal to 3. That is why we tell that this particular code is equivalent to decimal 3. So this code 0011 represents decimal 3. If we talk about other codes, then you see, let's say if I talk about this particular code, or you can talk about this code 9. So you see, if I talk, this is just equal to the binary. So if you will just represent the number in the binary system also, the code will be same. Okay, but for 10 it will be different. So for 10, if you have to write, we will see it later on. So for 10, if you want to write the BCD, what it will be 1 and 0. So 1 in decimal we will write it as 1 0. Okay, so for 1 you have to represent the 1 with 4 bits, then 0 again with the 4 bits. So if you write 10 in decimal number system, and you want the BCD code for 10 so it will be 0001. So the code for 1, and then the code for 0, so that will be 0000. So if you want to represent the decimal number in binary, it will be 1010, whereas in BCD it will become 0001 first group. This is for 1, and then for 0 it will be all zeros. So you can see that in BCD we represent every decimal digit by a group of 4 bits, and each bit will be given the weight according to this rule, which is